Okay, good morning, ladies and gentlemen. Welcome to the visiting lecture for today event with University of Custom and Finance from Ukraine. Welcome to the Honorable Miss Olena Parshyna. For the topic, for the topic is research of system by using the correlation and regression models. For first session, we will start with class today and continue with Q&A session, time for picture and closing. So let's begin. We will start for this class today. For Mr. Olena, the time is yours. Thank you.
Thank you. Thank you. I open my presentation. One moment. Okay, can you see my presentation?
Yes.
Yes, thank you. First of all, I can say you for this opportunity to work with you. This is my lecture. And today we can continue this topic by using methodology of scientific research. And today I propose to you a next part of my research by using research of system. We can say about technical system and economic system. Maybe we can use this topic for different type of system by using correlation and regression models. For example, I propose according this topic, we can say about methodology of correlation and regression model, and I can use different examples from my research by using this theory, correlation theory, and different models. Moreover, we can say about program software and different functions, mathematical functions, and methodology for analysis information basis by using different information about technical system and maybe economic system, social system, and so on. According this topic, I propose to you next points. For example, first of all, I can say about dependent phenomena. This includes the correlation. And I propose to you to say about this phenomenon correlation. Next, I propose to you to say about correlation relationships between variables. For example, we can form some basis by using information maybe about resources, maybe about energy, and analyze situation in our system. For example, we can analyze situation in our country, maybe in different country, for example, by using information about energy, resources, labor resources, material resources, and we can analyze main indicator like GDP, for example. By using this information, we can form models by using this theory, correlation theory, and we can analyze these models. By using these models, we can analyze situation in future. Moreover, we can compare, for example, one country and another country by using these models. In other examples, we can analyze different variables for some enterprise, for example. For first example, we can analyze, for example, 4 variables, material resources, labor resources, and we can analyze, for example, profit for this enterprise. We can form this correlation, relationships between, for example, profit of one enterprise, and we can analyze by using correlationships between profit and resources. So by using these models, we can form these models. We can analyze, for example, for situation for future for this enterprise. This idea, for example, I use for my research, scientific research for analysis different regional, for example. our region, Dnipro region, and we can compare, for example, situation in our region, Dnipro region, for example, and we can analyze Kharkov, Kiev, and other regionals in our country. So this idea we can use for different levels of economic system and social systems, for example. So I can say about this correlation relationships between different variables. And next, I propose to you, according our topic, to say about this simple regression theory. And I propose to use this regression theory for forming models, regression models, correlation models, and to say about how we can use this idea for practical, for decision making in economic and our society and in our scientific research. So according to this plan, for example, these points about dependent phenomena, about correlation relationships between parameters, between different variables, and about simple regression theory, I propose to use a first point. So I propose to say about this dependent phenomena. And I can say about this example, for example, we can analyze next phenomena like demand and supply, for example. You can see on my slide, you can see this picture, this law of demand, and we can say about correlation between demand for product and its price. So we can say, for example, you can see this line, and for example, we can say about correlationship between quantity and price, for example. So we can say this line, these points A, B, and C by using a different situation. For A, you can see information about a quantity Q1 and price P1. And next situation, for example, by using point C, you can see situation this quantity Q3 and price P3. And between N and C, you can see point B. So you can see these correlations between these parameters, between quantity and price. And we can say about law of demand. And this law of demand states if all other factors remained equal, we can say, for example, the higher the price of a good, for example, for point A, the less people will demand that good. For example, you can see Q1. And another situation, we can compare, for example, point A, this higher price P1 and less quantity Q1. We can compare, for example, this situation, this point B and C. For example, point C, you can say Q 3, it's less with compare Q1, and for example, for price, for point A, we can say higher price for A, then point C, this price P3, for example. I see about. Okay, thank you. And so you can analyze, I propose, for example, we can analyze this correlation. We can say for future, we need to form models, for example, and we can describe this line by mathematical models. For next, for analysis, we can say about direct correlation between quantity demanded Q and price P. for example. This picture on my slide, these points A, B, and C on this line. Demand line. For example, we can say each point for curve reflects a direct correlation between quantity demanded Q and price P. So at point you can see A, the quantity demanded will be Q1, and the price will P1, and so on for point B. And for point C, we can say about this analysis by using quantity and price. So for future, we can say about these variables, quantity and price. And our task to analyze this correlation, and moreover, we can analyze this correlation by using some coefficients. So we can say about this analysis by using some indicators of these correlations. So the demand correlation curves illustrate the negative relationships between price and quantity demanded. So we can say, so for future, we can say about next analysis, we can say about a positive tendency and negative tendency. For this situation, for example, between Q and price, you can see this negative tendency for future. For example, for different situation, this price and for Q, but for A, we can say about more higher price than for point C. And this Q, for example, Q 4.1 less than Q3 for point C. So we can say about these negative relationships between these parameters like quantity and price. Okay, and so for next analysis, the higher the price of the good, the lower the quantity demanded, A, for example, and the lower price, for example, like P1, the more the good will be in demanded in point C. Next, for analysis, another situation for supply. So I propose to you to compare this situation, this demand and supply. You can see another situation, these variables, this quantity and price, but for supply. You can see another tendency, another situation, these points, for example. And like the law of demand, the law of supply demonstrate where quantities what will be sold at certain price. But unlike the law of demand, the supply relation shows an onward slope, you can see. And this means then the higher the price, the higher the quantity supplied. So you can see for point A, by using quantity Q1, this price P1, and for supply, you can see next tendency. Positive, we can say about positive tendency. So for point C, you can see more price, higher price, and more quantity for point C. So point B between N and C. And according correlation between quantity supplied Q and price P, we can say these points A, B, and C are points on supply curves. This line of spline, another idea. But we can use this information because for some situation we can analyze by using a line model. For another situation, for analysis law of supply, maybe law of demand, we can use non-linear models. So for this, for example, for analysis, each point on this line, on this curve, reflects a direct correlation between quantity supplied, Q, and price for goods. For example, at point B, the quantity supplied will be Q second, and the price will be P second. So and on. For A, we can analyze Q1 and P1, and for C, we have information about Q3 and P3. For example, I can say about next situation, for example, we can analyze for future for analysis. For a real economy, we can analyze this approach for analysis correlation between different parameters. For this example, we can say about different type, for example, between parameters, and we can say about negative and positive correlation between different variables. For let's say about correlation relationship between variables. For example, we can analyze about this phenomena correlation, and correlation is a measurement of the relationships between two variables. We can say before that by using Q and P information. So for some situation, for some market, maybe about some goods, we can form information base by using information about quantity and price. And for different situation in this market, we can analyze situation for supply and for demand. For example, on this slide, for example, you can see negative and positive tendency. Positive correlation is a direct relationships where the amount of one variable increases, the amount of second variable also increases. For example, you can see this positive tendency. For example, we can say about information about X and information for this Y, for example. For example, we can say about progressive technologies for some enterprise. We can use more resources, material resources, maybe energy resources, labor resources, for example, like information for X. And we can analyze for Y, for example, we can say about this indicator like volume of production, for example. And by using this information, for example, we can say about positive tendency, we can say about this positive tendency. So we can analyze, for example, about the amount of variable increase, and we can say about information for volume of production. And also for this variable, we can say about also increases. Next situation, this negative correlation. For example, in negative correlation, you can see on this slide, you can see on this picture, as the amount of one variable goes up, for example, the levels of another variables go down. For example, you can see for X, you can see, for example, we can say about this maybe like example, we can say about maybe no non-effective technology. Maybe we can use more information about some resources, and for our volume, maybe of production, we can say about another situation, for example. So, but in both types of correlations, there is no evidence or proof that changes in the variable cause changes in other variables. A correlation supply indicates that there are relationships between the two variables. So we can say, and our task for future to say about this correlation, and by using this information about level of relationships between these parameters, we can say this information for forming models. Maybe linear models, maybe non-linear models. So by using this information, for example, for real economy, for maybe for real, I think about economic system, like maybe enterprise, maybe it's some region in economy, maybe more level of economy, we can say about country, and we can analyze different situation on every level. For example, we can compare different enterprises. For example, we can analyze and compare different regionals economy. And another idea we can say about different countries, and we can compare these countries by using, for example, for first level, I think about enterprise, we can use, for example, volume of production. We can on level of enterprise, we can say about some profit. We can analyze, for example, for different goods. And another idea for information by using information of volume on production for enterprise. Next idea, we can use, for example, this idea, but for example, volume of production, we can compare for some regional economy. And next idea we can use, for example, but for next level, I think about country, we can use next indicator. It's can be, for example, GDP. By using, we can analyze GDP for some years, but another idea, we can analyze GDP, these variables like resources, for example. So between different variables, we can say about this level of relationships. For analysis, we can use Pearson correlation coefficient. So we can, for example, analyze this level of correlation. For example, I propose, for example, for use Pearson correlation coefficients for analysis situation these variables. By using this correlation, we can say about next idea and our forming our functions. For example, for some situation, we can say about linear function, and we can use linear function for forming this model, mathematical model. For another situation, maybe we can use non-linear functions. For example, for estimation, this level between level of correlation between parameters, between variables, we can use this indicator. You can see this formula, for example, and we can say by using this determination, for example, first factor, it's our x, for example, like for my example, we can use resources, for example, material resources, energy resources, and so on. For second factors, we can say about indicator of our system. For example, For enterprise, it can be a volume of production, maybe profit, and another indicators. For example, for country, for analysis of country, we can use instant X resources, and instant Y, we can use GDP, for example. So our task to find this level and another idea, degree relationships. So by using this correlation coefficient between this information. Moreover, I can say for analysis, it's very important to say about some period of time. Maybe we can use some years, maybe some months. It's very important because for analysis and for using this information variables, we need to say about some basis, for example, information basis. And after calculation, this correlation coefficient, we can analyze about these degree relationships. For example, on next slide, you can see, for example, we can say about correlation coefficient. You can see, for example, this value of correlation coefficient, we can say between 0 and 1 unit. And by using information about this value of correlation coefficient, we can say about some degree relationships. For example, we can say about strong relationship between parameters for situation. So you can see 0.7 between unit. So for this, we can say about strong relationship, degree relationships. And by using this information, we can, on the next step, we can form mathematical models. And next, for analysis, we can use this information for analytical and for decision making by using this model. Next idea, for example, moderate relationships. You can see by using value of correlation coefficients 0.5 between 0.7, for example. By using this information, we can use this information for next analysis. And by using these variables, by using this information, we can form and we can say about moderate relationship. And by using this information, so for future, we can form models, we can analyze these models, and by using this information, this strong and moderate, we can analyze and we can form linear, maybe non-linear models for future. Situation between 0 and 0.3, you can see, and this indicator 0.3 between 0.5, it's weak relationships, and we don't use this information for modeling. So we can work for future this information by using correlationships like this. So when we say about strong and maybe moderate relationships between parameters, between variables. So about information in more details, for example, we can say about positive, we told about positive and negative relationships. So we can use about plus, another idea, this minus. So you can see, I return in my this slide, you can see plus minus, for example, 0.7, and you can see plus minus, you can see unit. So about value. By using value of correlation coefficient, we can say about this character of relationships between variables. But using this plus or minus, we can say about positive and negative relationships between variables. For example, before my pictures, you can see in this slide information about this positive and negative situation. This plus, for example, plus unit, for example, maybe instant unit, for example, we can calculate and we have, for example, 0.7, for example, maybe 75 before unit, I think. So in this case of a perfect positive increasing linear relationship, we can say. Another situation, when we have minus, for example, minus, you can see minus unit. Maybe another situation I return in my this table, for example, minus maybe minus 0.6, for example, and we can say about moderate, but we have minus. For this, in this case of a perfect decreasing negative linear relationship, we can say. So by using value, we can say about level of level, maybe we can say about degree of relationships between variables, between parameters. By using these signs, minus or plus, we can say about positive, negative. So we can say about increasing, maybe positive, and decreasing about negative situation. These are our parameters. And we talked about different values between 0 and unit. Moreover, we can say about different values between minus unit and plus unit. So in other cases, increasing of degrees of linear dependence between the variables. Between parameters. Also, we can use, for example, information about first about value by using value and by using signs. And for demonstration, you can see these examples, for example. So for analysis, economic system, for analysis, technical system, social systems, and so on, we need to form some basis and information. For example, for analysis economic system, we use information about development of country by using some years. For analysis enterprise, by using these approaches, scientific approaches, we can use information about development of enterprise. So by using some years, maybe some months for forming detailed information, for example. So you can see some points for analysis. And for picture A, you can see, we can say about this idea, we can say about positive tendency, and after calculations, moreover, we can say about our hypothesis about linear tendency, we can say, for example, by using this information. And after calculation, you can see we have our indicator, our correlation coefficients. You can see plus 0.82, for example. So we have plus, we have very high level for analysis and correlation between these parameters, between these variables x and y. Next idea, this B, you can see, for example, you can see level 0.7. So it's our I return in my table before slide number 10. You can see, for example, this one. So we can say about moderate degree of relationships. And next, I return on this, you can see minus. We have minus. So you can see on this graphic interpretation, so we have negative line, negative tendency. So on these pictures A and B, you can see by using information about plus and minus. So this plus, we can say about positive tendency, this minus, we can say about negative tendency. And by using value of correlation coefficients, for example, here you can see 0.82 and, for example, 0.7. So we can say about strong level correlationships and moderate level between these variables. So this idea you can see for forming linear models. Next idea, for example, you can see C, D, and E, for example. Another situation, for example, like example for C, for example. And you can see, for example, situation, this correlation 0, for example. Maybe for different situation, we can have, for example, I return in this table like this, before 0.3. So independent situation. And we can say between X and Y, we don't have some correlationships. And by using this indicator, we can say about 0 for indicator of correlationships. So by using this information and these variables and this statistical information, we don't use this information for forming models. But in other situation, you can see, for example, linear correlationship, you can see 0 for D, you can see. And for E, you can see 0 too. But another idea for this situation, you can see, for example, for this example, we can say about non-linear models. For example, we can say non-linear models may be second level for analysis. And for E, this situation, like for D, for example, we don't say about linear models, but for future, we can use another mathematical functions for forming non-linear models. But according our topic for today, for example, I propose to say about linear models, because this next topic, maybe we can continue maybe for next lectures. It's more complex information and more complex mathematical models for forming and for describing situation like D and E. But today I proposed to use this information, these linear models, negative, positive, by using this correlation theory. And very important information, we can use this information I turn on my table, correlation coefficient. Sometimes we can say we can use correlation coefficient for estimation and describing linear models. For linear relationships, we can use this indicator and we can analyze, for example, by using value and by using signs. Value, I think about For example, between 0.5 before unit, we can use for our analysis and for forming mathematical model. But idea for non-linear models, it's next topic, and we can use different mathematical functions for describing non-linear models. So I propose to continue by using this information, and according my plan for today, I propose to you first to say about this theory, about correlation and regression theory, and on the next part today, I am going to say, and I can show you my calculations by using information about X and Y, and forming these models by using different ways. For example, what I can say about, sometimes we can use many formulas, and for example, we can use program soft like Excel. I think you use this program soft too. We can form many formulas, we can form many tables, and we can form these formulas like correlation coefficient. And for another, we can form many tables for calculations. It's first approaches for analysis. And next idea, for example, by using this theory and by using this program soft like Excel, maybe another idea, we can use another mathematical program soft like Passcode and MATLAB, for example, by analysis this information. And we can use many formulas from this program soft, and analyze situation with indicators and parameters, variables, and so on. So before these examples, I propose to you to say about this simple regression theory, but about simple, it's we can say simple because we can say about only two parameters. In real practical calculations, it's not simple because do you remember about very long formulas, many formulas for analysis, and we can use some program soft for calculations. So first of all, I propose to you this graphic interpretation. For example, you can see simple regression line. It's line, simple regression line between, for example, two axes, X and Y. Do you remember, for example, about it's about mathematical approaches only, but in real practical, we can say between, for example, resources instant X, for example, and instant Y, we can say about situation, for example, maybe we can analyze GDP, maybe we can say for enterprise volume of production, maybe profit, maybe cost of some project, and so on. So, for example, so first of all, we plot on the first step. We plot some data points on graph interpretation and draw a line through them to indicate their general tendency, for example. And for example, that action is called simple regression. And the line that we draw is called a regression line, for example. So we can use these determinations for next analysis. So we can analyze, for example, some information. Like example, for example, we can say about analysis some enterprise. Maybe we can say about instant X, for example, resources, more detailed information we can analyze, for example, labor resources, material resources, energy, financial resources. So, for example, for every X, so we can use, for example, X1, we can say energy, X second, we can say about labor, X3, financial resources, and so on. For complex analysis, I propose for example, to summarize x1 plus x second plus x3 and next, for example. So we can say about general resources of enterprise, instant X. And for Y, we can say about maybe profit, maybe volume of production. And next, for these points, I propose to use information about development of enterprise for some years. For example, we can analyze situation this 10 years, for example. And for example, we have 10 points for analysis. So we can form this plot. These are our points. And like for picture before that, I return on this like that, for example, you can see. And we can draw this line. So our hypothesis, we can say about tendency, linear tendency. So we can say about this regression line and our points. So this action in general, we can say simple regression. And next, for next situation, you can see for our analysis, we need to form mathematical model. And on this slide, you can see this simple equation. For example, y is equal a plus b multiply x. So this formula, we can say about formula for describing this line, this regression line. And for next, our task. So we have information about x and y, and our task to find a and b. A and b, it's our parameters. We can say about our parameters of our mathematical models. It's very important for modeling, for future modeling. But for explanation about A and B, you can see X and Y, for example, our task to find relationships, to find model between resources and, for example, volume of production. And you can see, for example, what is A and B. On plot, you can see A, you can see, we can say about the line's intercepts is a distance A. On this graphic interpretation, you can see this A, for example, and B, about B. The slope of the line is B. You can see, for example, the slope is how much the line raises. You can see on this elementary explanation, for example, you can see it's a unit of distance v more to the right, for example. You can see unit and this distance, it's b. Unit next between instant. Our unit for this example, it's our years, for example. So I propose to analyze situation. We can say about information about enterprise, for example, for information about during years, for example. And its unit, for example, it's our year, for example, between years. So our task for future to find, for example, this value A and B. Another ideas and another determination we can use next. We can say about variables x and y. So we can use only two variables for simple regression theory. And A and B, we can say about parameters of our mathematical models. Our task to find this A and B, and next our task how can we use this regression line? First, we thought it's very important. We can use this regression line for prediction. For example, it's very important for this situation. For example, we can analyze, for example, by using 10 years, and we can analyze situation this some enterprise. Another idea, for example, we can analyze situation in this country by using these years. For example, this idea, for example, it's very important to analyze how we can use different kind of resources, for example. And for future, for example, it's very important about decision making for future, about labor resources. I change my slide, for example, about instant X. For example, we can say about resources for future. And for prediction, for example, you can see for future. For example, last point, for example, we can use information about 2023 year, and by using this tendency, for example, we can say about for future, and we need to plan for 2024, for 2025, and so on, for example. By using this tendency, and very important to say about, for example, prediction, it's first idea. And next idea, we can use this mathematical model for interpretation of simple regression results, for example. I can say, for example, this idea about prediction, about forecasting for future. It's very important for economic system and for social system, social and economic system. For technical system, for example, we can use this idea. We can say about interpretation of simple regression results, and it's very important. Let's continue by using this information. For example, for first idea, we can use this regression line for prediction, for example. You can see, for example, after calculations, our parameters of model, I think about A and Y, for example. We can analyze, for example, you can see, we can say about start here, for example, in this point by using information about X, for example, about resources. And you can see we can draw this our regression line, and we go up to this regression line, you can see, and by using this regression line, we can go left from the time line by using this x, y, and we can say about this value for y. For example, for analysis, for enterprise about volume of production, maybe about profit for next year, for example, we can say we have this regression line, we can say about tendency, and by using this tendency, by using this graphic interpretation, we can analyze situation what we will have this volume of production, for example, for next period of time, for example. It's very important. Next idea, I think about interpretation of simple regression results. For example, for technical systems, we have some regression line, and for different situation, for example, we can analyze a regression line tells you estimate of effect on y of a change in x. So we can change in our resources, and we can analyze situation for enterprise, this profit, for example, maybe another situation for social and economic system on the level of country. We can say about situation, for example, we can change in volume in X, for example, we can change, for example, resources, labor resources, energy resources, and we can analyze situation in this X. So this profit, this GDP, and other indicators in general. It's very important. So first of all, we can say about explanation in our situation in our system, and we can form some basis for decision making these different kind of resources. It's very important for currently situation. For example, we can model a situation with volume of resources, energy resources, material resources, labor resources, and we can analyze situation these main indicators of system. So our task to find our parameters for analysis. We can say about forecasting, we can say about explanation in our system, economic, technical, social system, but our task to find A and B, to find our parameters of our models. So I propose by using this idea to say about this method for estimation. Very important to find estimation of parameters. This method we can say about least squares method. So by using this determination, you can see linear models like this. You can see this form. We talked about x and y. It's our variables, but we can say about x. It's independent variable, but our y sometimes we can say y from x. We can use this determination, like this model, mathematical model, x, y from x. So y from x is our dependent variable, because by changing our x, we can say about another value for y. And in this mathematical model, you can see, for example, two parameters, A0 and A1. So it's our parameters. Sometimes we can say about coefficients of our linear models, parameters of our models. And our task to find these parameters, for example. According these methods, least squares method, we can say next determinations, for example. So first of all, we need to form, for example, statistical information about our system. In my slide, you can see, for example, we talked about analysis economic system for enterprise, maybe for country. Instead, for example, we can say from 1 to n, for example, we can analyze, for example, about 10 years. So this indicator, we need to form 10 value for x and y. So maybe information between 10 years for enterprises, maybe 10 years for analysis country. It's very important because we have 10 points, and by using this statistical information about some period of time, we can form analysis, we can form graphic interpretation. And on the next step, do you remember about idea last lecture about methodology? We can form some statistical information, and by using this statistical information, we can say about hypothesis. For example, we can say about some tendency, we can say about maybe linear tendency, maybe we can say about non-linear tendency. By using this method for situation this linear tendency, we can say about next. We need to form our models. So we need to form the module function. For example, you can see f, you can see in breaks, you can see from x and y. And for calculation our parameters a and b, another idea I return in this a0, a1. Sometimes we can use this model. Sometimes we can use another idea like this view. For example, A and B, like this, you can see. In some literature, you can say and you can use this view of function. Maybe sometimes you can see this view. But for first example and second example, for A and B, and for this example, A0, A1, it's our parameters. It's our parameters of our models, sometimes coefficients of linear models. So our task to find these parameters, and for these parameters, we can use this least squares method. It's very important to find this sum, and you can see this formula. But for explanation, what about r in square? You can see this information. We can find y. You can see its first component for calculation, it's our statistical information for our system, minus this value, it's this second component, it's our model function. So by using, we can find this value by using some formula, this formula, for example, like this, by using this indicator. So for explanation and by using these calculations, I propose to you to continue my lecture, and I am going to find you with my calculation for explanation this theory, for explanation how does this method work, for example, by using some statistical information. So, for example, for next, first of all, we need, for first step, we need to form our statistical information, this X and Y. For next step, we need calculate our coefficient of determination. And on the next step, we can say, and we can use these models for prediction and maybe for explanation our situation. One moment for explanation, how does it work? I propose to you to say about some process calculating linear regression, for example. And before that, do you remember we talked about this information? We talked about next ideas. We can use different ways. For example, you can say about, for example, you can see on my plan, for example, I can say about this this forming this linear regression. We can use many formulas. For calculation, we can use Excel. For example, I can use Excel, this program soft, because it's very comfortable to form many tables and create many formulas. And moreover, we can form graphic interpretation. It's very comfortable to work. Next idea, we can use formulas. For example, you can see second way, we can use linearest function for calculating regression line, for example. It's second way, for example. And next, we can say about significant estimation of regression model, because we can use these models for our real practical, for example, decision making. For example, we analyze, for example, situation, and we can describe resources and GDP on the level country. Next idea, we can use this idea for enterprise resources and volume of production, and so on. For first, we can form statistical information about our object, about our systems. Next, to form this information basis, and next, to form to use these mathematical models, maybe functions, maybe first idea by using regression line, by using many formulas. So let's to say about this. I am going to use these ideas by using formulas and this linear's function. In this way, we can compare by using many formulas and by using linear function. So let's to use, for example, first of all, we can say about average value and linear regression. It's very important for analysis and for calculations and for next many formulas. So let's to analyze this graphic interpretation. You can see these blue points, you can see, and you can see, for example, this first graphic interpretation with red squares, for example. So next idea, it's very important. We need to form the beta linear regression. On, for example, you can say on the right, you can see, for example, some points, it's our statistical information, and we can draw. Do you remember from first part of my lecture? We can draw this line, this line form, regression line, for example. And we can analyze, for example, next idea. This line is average value between our statistical information, our point, you can see many points, for example. And for analysis our level about, and we can say about level of beta line regression, we can use value, you can see R in square, for example. And we need to calculate information about R for next my presentation. You can say about these definitions, for example. Let's to analyze these mathematical definitions, for example. First of all, do you remember about y? So, first of all, do you remember, we need to analyze about our systems for some period of times. Maybe it's 10 years. Maybe it's 10, maybe 12 months during some year. And so we need information about some period of time. So we can say about some situation, we need more than 1 or 2 points for analysis. So for first step, for example, we need maybe 10 points for analysis. For example, I can say about our students and our diploma paper, for example, for analysis, we need to use information about enterprises, maybe about information about regional economy during some period of time, 10 points, for example. For example, national economy, for analysis of national economy, for example, we need 10 years for analysis. So, for example, we can use some indicator instead y, it's statistical information about important economic, maybe financial indicators for analysis. Maybe GDP, we talked about that. Maybe for some enterprise, we can say about a volume of production, maybe profit, and so on. For complex analysis, I propose for my students to use many indicators for analysis, and we need to compare, for example, maybe different countries, maybe different enterprises in some areas for analysis. And we need to compare maybe first enterprise, second enterprise, maybe next idea we can compare first technology, next technology, by using, for example, resources and maybe cost of production, maybe cost for investment, and so on, for example. So we need some statistical information about system. Next idea you can use. Next idea, for example, for calculation, this indicator R in square. I return in first slide. You can see, for example, we need this indicator, this value. We need to calculate this indicator, this value R in square. And by using this indicator, we can say about level of correlationships between parameters between these indicators, and analyze, for example, this regression line for future. So I return on these mathematical calculations. So for calculation, this R in square, we can use first formulas by using this component, and next idea. For example, and next you can see, for example, for first, we can use by index chart, you can see, for example, this one. For example, we can calculate the total sum of squares. So how we can use? It's our statistical information Y with index I. And next Y, it's our average. It's our average. For example, I change on first my slide. You can see this one, average line, for example. Average value from our statistical information. For example, for situation, for example, we can say about GDP during 10 years. We can use GDP. We can summarize this GDP for during 10 years and divide it by 10, for example. So we can have this average value of GDP during some years. So this idea we can use for enterprise. So by use sum and in square, we can say about total sum. Next, you can see this index regression you can use for regression. For example, our F, it's our model. It's our value. We can calculate this value by using our model, linear model, and minus our average sum. So we can say about regression sum. We can use this determination in my examples. And next, you can use by index R, you can, this blue indicator. You can see another, we can use statistical information minus our model, our value that we calculate by model in square. So we can say about the sum of squares of residuals. And for example, you can see our dot, this red indicator you can see in this formula. For example, it's our sum, our regression, and these residuals. So you can see many formulas. I think it's this slide you can see for your view in general. But next, I propose to use for a real example by my calculation. Maybe I can change for this information. But for my explanation, I propose you for calculation to use, we can use the linear's function for calculation linear regression. So first way, it's many formulas. For analysis, we need to form tables. And another way, second way, we can use function, for example, from Excel, this linearest function for calculation linear regression. You can find this linearest, this function, these parameters. I can explain by my example about these parameters too, for forming these linearest models. So let's to analyze, for example. Do you remember I propose next way, because this determination, this M and B, you can see, and this formula, linear formula, we can use this formula and this explanation like in Excel program, in program Excel, for example. So do you remember about X and Y? X it's our first variable, Y independent. Do you remember from first my lecture? X it's our independent variable. For example, it's resources. And Y it's dependent variable, because we can calculate Y by using formula. And M and B and this view for mathematical model, sometimes it's the same. We can say it's the questions. We can say about parameters of our models. So, do you remember about first part of my lecture? We told by using graphic interpretation what is M and what is B. So, do you remember? Yes, M represents the slope of the line, for example, for situation with positive tendency, and B represents the y-intercepts. Do you remember from my first part? So we know by using this idea about every component of our models. Next, about using this linearest function, for example. For example, we can form many formulas, but another you can open Excel and you can find these linears. Next idea for this formula and many important information about using linearest function. It's next. Before creating some formula using linearest, you must select a range by using this linearest from functions, and you need press Ctrl Shift Enter to enter the function in some cell for calculations. So let's let's to analyze on my example. So I propose next idea, for example, by using these linear functions, you can form next table, for example. Moreover, for different situation, do you remember about my first part of my lecture? We talked about models by using only one X. But before my lecture, I told about that. We can analyze, for example, our system by using more than one X, for example. For example, I have task to analyze in more details situation in our economic system, for example. For example, on regional level, maybe national level. So for production, for every production, we need different kind of resources. So we can say about energy, financial, about labor, about different kind of material resources, and so on. So we can say about X we can use, for example, for X first, we need, for example, energy resources. For X second, we can use labor resources. For X3, we can use, for example, material resources, and so on. So very important information, by using linear function, we can form more complex function by using non-one X, by using some access, for example, some resources. You can use, for example, indicator M by using n minus I, M second, M first, and B. I return for explanation. Do you remember about this view, for example? But instead, this view, this only one X, we can use this formula for more complex system by using X first, X second, and so on. So we can say M first multiply X first plus M second multiply X second plus M3 multiply X3, and so on. So we can use more complex formula than only one X. So I change on this. So this one, and you can see, for example, we told this my table about regression sum, you can see, and regression value for analysis. So you can see this one. And this information I can explain step by step. So let's to analyze situation, these formulas for my table, and by using linear function. On my next slide, for example, you can see it's information for forming analysis. Let's I explain situation. You can see X and Y. You can see this yellow area. It's my statistical information about some object. For example, first, second, and before 7, and information this Y. This our statistical information. Next, you can see this information, you can see in red area. It's information by using formula function linearst. Next, you can see I explain this component, and on my next slides, I can add information and explanation for every component. Next, you can see green area, this trend function we can use. Next, you can see blue area model. You can use this model by using m multiply x plus b. You can see this model. And these calculations you can use, for example, you can see it's our sum for our error and our regression sum. You can see this calculation. And on this plot, you can I can form this plot by using these options. For example, you can see this line by using my statistical information, this one. And line, you can see this regression line. By using information, you can see by using this formula, instant this model, you can see. So M, we have 90.5 and B, you can see 7. So for this slide, I can say about every component on my calculations. You can see some part these formulas. It's very important formulas from my table before this part of lecture. And you can see this red area. It's our likeness function. And on this graphic interpretation, you can see this graphic interpretation, these points and regression line. Let's step by step for explanation. You can see, first of all, you can see it's you can see in this cell, you can see I can use linear function. But for explanation, you can see in Russian Excel, but its function you can find in English linear. It's the same. For example, you can see in Russian variant, but its function linear about our function for some. We can use this function by using Ctrl, Shift, and Enter. You can use, for example, by using this linear, we can use this area. For example, you can see this from B3, B9. You can see from 20. You can see this area. For example, this area for information and information about about why you can see B3, B9, this one. And next, about information about X. You can see A3, A9, this one. So by using this area, this information about statistical information, we can use this lineist, this function, press Ctrl, Shift, Enter, and we can calculate this one, for example. Its first component. Next, for explanation, you can see, after that, you can see I have information about M and B after using my linear function. You can see on this cell D3, this one, please. And you can see forming my linear function and my model. I can form formula. You can see A12, this one, it's our M, multiply A3, A3, it's our, you can see, it's our X. In this cell, you can see unit. And plus, like this model, plus B. B, it's our, you can see, B12, this one. So, by using linearest function, you can calculate value of parameters our models M and B, and after that I can form my model. So for every x, I can calculate this theory, this value by using model, this value by using regression line. Regression line, you can see y is equal m multiply x plus b. So this one. For every cell, I can calculate this value by using this formula. So you can see this explanation on this step. Next step, you can use next calculations. We need to analyze this sum, this error. You can see. What is this? You can see this formula. This formula, it's copy from my table. You can see it's sum. Y, it's our statistical information, this one, minus it's our theory, it's our model. So you can see in this cell, you can calculate B3, you can see it's our statistical information, this one, minus, you can see this form, minus our theory. Our theory, it's our D3, this one. So I can form this calculation by every x, you can see by every x in this area, by using this formula. And in cell, you can see E10, this one. In yellow, you can see. I have this sum. So this one. So by using this formula, we can use sum of these calculations between our statistical information, this one, and our models. So you can see for every cells, I can use this formula and I can calculate the difference between statistical information and our theory value by using our model. After that, I can use to summarize, to sum, and calculate this value. So this one. Next, on next step, you can see next this green formula. Next sum. You can see it's sum like the same, but we can use our theory, our model value by using our model minus average. So average between our statistical information for our y, for our value y. So you can see this one. You can see for explanation my formula. We can use for our theory, you can see F, it's our model. You can see it's our, you can see S 3, it's our model. It's the same. It's the tendency trend function model. I can add explanation for this slide. We can use 2 ways for calculation our theory, our models, our function. We can use model by using information, by using our function lineast, like this, and another way, we can use formula trend function. You can find lineast, you can find trend, these functions in Excel, for example. And you can see, you can compare these values, you can see it's the same. So for forming theory model, we can use 2 ways. We can use like blue area, you can see this model by using this formula, but instead M and B, we can use this value from our function lineast. And second way, we can use the same, but by using trend function. So for calculation this sum, you can see our theory, it's our theory, minus you can see B10. It's our average value between our Y. So I can calculate for every X, it's the same approaches. And after that, I can use to sum. You can see this value for some regression. So the next way, you can see, for example, this sum, this one, it's some information about this difference. And next, the same, this one, it's sum for this difference between theory and average value of Y. So you can see about this value. And next, I can analyze next interesting information about function lines. You can see, let's compare information in last value in this red table by using function lineast. You can see this one, this value, you can see it's our sum regression, and this one, it's our regression between statistical information and theory. So first, it's our sum of regression between theory and average, and second value, this one, between our statistical information and our model Y. So it's you can compare for analysis. And this one we can say about lineast function. Lineast function, I repeat about information. We use statistical information about X and Y. So I can analyze next idea, next information you can analyze, for example. My explanation about trend function. It's a Russian version of Excel, but in English version, you can find trend function like this trend. You can it's practically the same like alignest function. You can use trend function between this information, this statistical information, this X and Y. You can see first it's information about B3, B9, this one, and next A3, A9, this one, information about X. So for this information, we can form this trend function, and you can compare, you can see it's the same. I think about calculation by using formula M multiply X plus B, and M and B, we can use information by using line nest function. And this maybe we can say about second way for the calculation theory value for Y. It's by using formula, by using function trend function. So its formula, its function for analysis tendency. But we need say for first way, this linearness function, we can see value M and B. By using this function, you can see only a value Y. So you can compare this information. It's very important. It's for analysis different functions for using and for forming theory value. But I propose to use this way, this line nest function, because on the next slide you can see information, this graphic interpretation. You can see, let's compare, for example, this red area, this red table, it was formed by using line nest function. And this one, it's our M and B. We can compare information by using this idea. For example, on graphic interpretation, you can see this line by these 7 points. So first graphic interpretation we can form by using statistical information, by using statistical information about Y and X. But this line we can add by using some ways too. For example, first way, I can form this graphic interpretation by using this information, and I can this information by model. Another way, I can add this option by using tendency, trend function. So, and you can see, for example, this one, this value, you can see it's our M, and this one, it's our B. It's our B by using, so we can compare by using formula line nest by using formula trend, tendency formula, and you can see, for example, information for every component in this alignest formula. So I change you can see this information. I change in my explanation this one, you can see alignest function return the values. So M, for example, and B for our statistical information, it's our M, maybe M first and B, M and B. Next, it's our regression you can see, and it's our sum of regression. I return on this one, you can see this one. Regression, you can see this one. It's formula. It's a formula from our first table. And you can see this. What about regression? Regression sum of squares. And this one, regression, the sum of squares of residuals, for example, this one, these formulas we can use for analysis. And total regression, it's sum of these components. So by using this, I compare this one, we can analyze. So this area we can say by using our line-nest function, we can use this component for forming our model. And this one we can say about our sum. And last, you can see information by using R in square. So you can see 0.97. Practically, we have unit. We can say, I change in my first slide. We talk about this information. So you can analyze, for example, we can analyze, we can form this R in square. So, and by using this line, by using this indicator R in square, we can say about our model, and we can say about level of correlationships between these parameters. So by using this information, I change on this slide, for example, let's in last, and we can analyze, for example, we can say about information, we can compare this information, for example, and by using these functions, we can use this model for analysis. I can add information for significance estimation of regression model. We can use Fisher statistics, for example. For first, we can use significance level 0.05, and we can use regression. We can use information about degree of freedom, for example, and regression model as acknowledging significant, for example, for calculation. Our value f must be more than information from table. This information you can compare, for example, by using statistical information. And very important idea we can use, for example, after that, we can say about correlationships between parameters, and we can use these models for analysis in general. So we can use this information for analysis for future, for example. Let's, for example, it was 7 from 1 to 7 years, for example, points we can say about next for prediction and so on. So it was our lecture about using simple regression theory.
I'm apologize, Miss.
Yeah.
Our time presentation is 10 minutes again. Thank you.
Yes, yes, yes. I can I can say about all my presentation and this theory. Maybe do you have questions about these approaches? Maybe do you have questions about these calculations? Please, I can say.
Pardon?
Maybe difficult information, but I try to use my calculation this more complex maybe example, and to compare different ways for analysis and to use mathematical models, to use functions for forming linear regression for analysis different systems, for example, this information, this X and Y.
Is it enough for presentation, Miss, or no?
Maybe do you have questions? Maybe
Or
maybe students have questions about these approaches.
yes, we have two questions from participant in the chat. For first question from Mr. Amin Tohari, what
I,
might be limitation or problem associated with using correlation and regression, and also how are regression analysis used in research? That's all, and thank you so much, Miss. Yeah, that's all for from question from Mr. Amin Tohari. Maybe you can answer it, Miss.
okay, in chat. Okay. One. Use regression. Okay, I see. Problems with using correlation and regression as used in research. Okay. We have many interesting information, and our students to use this regression theory. We can use these approaches, and you can use this idea for analysis different situation. We talked about, for example, I use information in general, for example, by using X and Y. We can use for I can say we can use information. First of all, we need to form maybe statistical information. Maybe after you experiment this technical system, maybe, but for statistical information, for economic system and social system, I think not problem for forming. I think about forming information base. After that, you can use maybe many formulas I can compare to, say, by using these formulas. Maybe you can use only linearest function to form and add graphic interpretation. It's very, I think it's not problem for different systems. And it's very important to say about analysis between different parameters, between different factors you can use for analysis of resources, you can use for analysis by using main indicators of different systems. For example, for economic, you can use GDP. For general resources like this, for this lecture, I can say about only one X. But maybe we can continue these ideas, and I can say about many factors instant X, for X1, X second. Like example, we can use different kind of resources. This idea. Another idea, you can use different information instant X, and you can analyze these correlationships, you can analyze these relationships between parameters, and by using these models you can say about forecasting, you can give explanation for functioning technical system, economic system, and so on. It's very important idea for finding relationships between parameters, different parameters, and to use these models for analysis, for analytical researches. Thank you. I see. Thank you.
Okay, thank you for answering. And the last question, how can the application of correlation and regression model enhance the research methodology in studying complex systems? And what specific considerations should research keep in mind when utilizing these statistical tools for analyzing relationship within the context of system research? This question from Mr. Sukamta. Thank you.
You can use, okay, one analysis relationship in the context system research. Yes, I see. We talked about methodology of research last time. And first of all, first lecture and information about methodology. We can use, for example, from first step, second step, and so on. For example, on first, we can use statistical information. We can form this statistical base for analysis. On the next, we can say about hypothesis. We talked about different hypotheses last time, in last year, in December. Do you remember? So we can say about hypothesis between our parameters. We can say about tendency positive. We can describe by using graphic interpretation. Next idea, you can see, for example, maybe negative tendency. By using these mathematical approaches, we can describe situation in negative processes, in positive maybe processes. And very important, after forming mathematical models, we can form forecast for future. And by using this forecasting, we can form decision making. It's very important. So we can form this correlation, regression, linears, and we can describe our researches. We can form models, linear, non-linear, but for non-linear, it's next topic. For example, by using linear models, negative, positive tendency, we can forecast for future. It's very important. And after that, we can form decision making by using this modeling. So it's very important for currently situation in every areas, in economics, in social, in technical. So you can use different parameters, and between these parameters, between these variables, you can find relationships. After that, by using this methodology to say about forecasting, and by using this information to form decision making.
Okay, thank you for answering. I think it's very clear answer from Professora. Okay, before I close this event, for all participants, please open your camera. I will take a picture on the count of three. 1, 2, 3. Okay, another one. 1, 2, 3. Smile. Okay, thank you for your keen cooperation. Finally, we come to the end of visiting lecture today. We would like to thank you for Miss Olena for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have more collaboration in the future with University Custom and Finance. The visiting lecture for today and here. We hope to see you soon. Thank you and have a nice day. Thank you so much for Miss Olena Parshyna. Thank you.
Thank
Goodbye.
you. Thank you. It's very interesting to work with you. Thank you. Thank you for participation in my lecture too. It's very interesting to say about my research. It's only part of my research and methodology in this area for analysis, for analytical, to use analytical technology for analysis of different systems, economy, technical system, and others problems. Okay.
So much. We're so glad to have you in this occasion today. Thank you. Goodbye. Bye.